Hello everyone. I hope you all are doing great. Myself Dr. Firoza D. Mirajkar, and today we will see a MATLAB program on how to calculate linear convolution and verify its properties. So here this MATLAB program, it will demonstrate the commutative, associative and distributive properties of the linear convolution. Convolution, it is an important operation in the signal processing, especially in the context of linear time invariant systems. The program plots the results of these properties using stem plots and displays the output sequences for the comparison. So here we will start our program with the three basic commands, that is CLC, clear all and close all. As you all know, CLC is a command which will clear the command window and resets it to a new state. Whereas clear all, it will clear all the variables from the workspace, and close all will close all figures and the windows. Now we have to initialize the input sequences, for which we are using these three lines in the program, that is x is equal to input, enter the first sequence, then h1 is equal to input, enter the second sequence, h2 is equal to input, enter the third sequence. So once we give the input by using these three lines, that is x, h1 and h2, next we'll be going to verify the commutative property for the linear convolution. The commutative property of linear convolution, it states that x convolution of h1 should be equal to h1 convolution with x. So first we will verify the LHS, that is first we will calculate the value for the LHS. For that we will take that value to a variable called as y1. So y1 is equal to convolution of x comma h1. This conv, it is the convolution command, which is a function used for convolution operation. And once we get the value for this, here we will plot this by using the subplot command, that is subplot 3 comma 2 comma 1. Here we are using 3 rows, 2 columns, and we are plotting this y1 in the first quadrant. Next command is n is equal to 0 is to length of y1 minus 1. Here this command, it is used for the time axis. Now we will use the stem command to plot the result. Next we are using the grid on command, which will display the major grid lines for the current axis. And after that we have to name the labels, that is we have to name the x-axis, for which we are using x label, and x label is given as time. For y-axis we will be using y label, and y-axis will take it as magnitude. Now we have to name the graph. So for that we are using the title, that is we have to give the title to the graph. So the command used is title. Here we are giving the title as linear convolution. What it is? It is the linear convolution of x and h1. Now next we have to go for the RHS, that is h1 convolution of x. For that we'll be using the same commands, just we have to replace y1 by y2. That is we'll be taking this RHS as y2. So wherever y1 is there in this part of the program should be replaced by y2. Okay. So here y1 was there, we are taking it as y2. It was convolution of x comma h1, but our RHS is convolution of h1 and x. Therefore we have to take it as h1 comma x, and we are plotting this in the second quadrant. So here 3 comma 2 comma 1 was there. Now it will be 3 comma 2 comma 2. That is, this signal was plotted in the first quadrant and this signal will be plotted in the second quadrant. Remaining all the commands remain same, just you have to replace y1 by y2. Now we want to verify whether the LHS and RHS are equal. For that we'll be using the if else statement. Here if y1 is equal to y2, it has to display commutative property of linear convolution is proved, or else it has to display commutative property is not verified. Okay, and you have to end this if else statement. Next we have to verify for the associative property. So associative property is stated by x convolution of h1 convolution with h2 x convolution h1 convoluted with h2. So again for this same part of the program we will copy and paste here, but wherever y2 is there we will replace it by y3. And here if you see the LHS, first x is convoluted with h1, so for this we are taking convolution of x convoluted with h1, that is convolution of x comma h1. The result of this it is convoluted with h2. So once again we are using another function convolution, that is convolution of this, its result is convoluted with h2. Okay, and remaining all commands will remain same as it is y3. It is the third signal which we are plotting, so we will plot that in the third quadrant, and wherever y2 was there you have to replace it by y3. Next we have to check the RHS of this. So RHS of this is h1 convoluted with h2. This result is convoluted with x. So for that again we have to use here two con functions, that is one for this bracket term and its result will be convoluted with x. So first we'll find out con of h1 comma h2. Its result it is convoluted with x, that is con of x comma this. Then remaining again all the commands remain same, but we are plotting this in the fourth quadrant, so you have to replace this 3 by 4 and remaining all the commands remain same, just you have to replace y3 by y4. Okay, now we have to verify whether associative property is verified. So here again you have to use the if else statement. If y3 is equal to y4, it has to display associative property of linear convolution is verified, or else associative property of linear convolution is not verified and you have to end it. Next we will go for distributive property. Distributive property, it states that x convolution of h1 plus h2 is equal to x convolution with h1 plus x convoluted with h2. Okay, now again the same part of the program you have to copy and paste here. Just you have to take this as Wi-Fi now, because we are going or we are plotting the fifth signal, that is Wi-Fi, and you have to change this. What it is, LHS is h1 plus h2. Okay, first you have to find out h1 plus h2, then x is convoluted with h1 plus h2. So it should be written as con of x comma h1 plus h2. Again all the commands remain same here, just you have to replace, previously it was 4, now you have to replace it by 5, and wherever y4 was there you have to replace it by y5, and the title should be changed. Okay, in all the parts of the program the title should be changed. If you are going for commutative property you have to write it as commutative. If you are going to verify the distributive property you have to write it as distributive or associative. Now we have to find out the sixth signal, that is y6, that is for the RHS of the distributive property. So for that again we'll copy and paste the same program, part of the program. Here first we have to find out convolution of x and h1, then convolution of x and h2, and we have to add these two signals. So here again we are using two commands, same commands, that is con of x comma h1 plus con of x comma h2, and we want to plot this y6 in the sixth quadrant. So we will replace 5 by 6 and remaining all the commands remain same, just replace y5 by y6 in this part of the program, and the title will be distributive property and the RHS which we have written here. Now we have to verify whether these two are equal or no. For that we'll use if y5 is equal to y6, it has to display distributive property of linear convolution is proved, or else it has to display distributive property is not verified. Okay, so here it should be display. Fine. So this is the program. Now we will run the program and see whether it executes or no. So for that, here you have, so I have made some changes here. I will save that first, then I'll run it. Okay, there are no errors. What is the first, what it is displaying? It is displaying the first message as enter the first sequence. So we'll enter the first sequence in the square bracket. Always you have to enter the sequence in the square bracket, otherwise it will display as error. Therefore here 3 space 1 space 2 space 1. Okay, then the second sequence is 1 2 2 1. Then the third sequence will be 2 4 2 4. Enter. So here first we'll see what it is displaying in the command window. Here these are the values for the linear convolution of the two sequences, that is 3 7 10 10 7 4 1. And here this is the LHS of the commutative statement, and this is the RHS of the commutative statement. You can see both are same, that is both are equal. Therefore commutative property of linear convolution is proved. Next, it is for distributive, it is for associative property. Here these are the values for the associative properties. So you can see all the values are same. These are the values for the LHS, these are the values for the RHS. So all the values in the LHS and RHS are same. So associative property of linear convolution is verified. Next is distributive property. So these are the values for the distributive property. Again you can see these are the values for the LHS and these are the values for the RHS. All the values are equal or same. So distributive property of the linear convolution is proved. You can change the values of the input sequences and you can check for the other results. Now we'll see the figure window. So here in this we have used the subplot command. So subplot was 3 2 1 2 3 4 5 6. Why 3? Because 3 rows. Why 2? 2 columns. Okay, here this is the first quadrant, second, third, fourth, fifth and sixth. First and second quadrant, these are for the linear convolution. Here third and fourth are for associative property, verification of associative property. These first two are the commutative property. These two are used for the verification of the commutative property. Actually I should have written here commutative property, or even you can write it as linear convolution of x comma h1 or x convolution of h1. And the fifth and sixth quadrants are for verifying the distributive property. So I hope you all will understand this program. If you have any doubt in this program, you can comment so that I can rectify your doubt. Thank you.